Welcome to everyone. I am Shravanti, Assistant Professor from Artificial Intelligence and Data Science Department. Today I am going to take adversarial search. So this topic is very important while coming to game theory. In this we will see two important algorithms, minimax and alpha beta pruning. In this particular lecture, I am going to cover what is our basic concepts of adversarial search and minimax algorithm with the example, alpha beta pruning with the example, and the last thing is I am going to cover gate questions along with the solutions. Okay, adversarial search. This particular searching algorithm uses in game theory. So, what is mean by game theory? Okay, if you take real-time game applications, in this we will take chessboard itself. Here we will have two agents, or we can say two players, A1 and A2. These two players will compete between each other. So, if these two players, they will compete among with each other. Okay, if you think only there are two agents or two players, no, there are more than two players also, or more than two agents also. If you take virtual football player, virtual football game, in this 11 players will compete with each other. So the main motto is, what is the main motto is how these players are competing with each other. So for A1 and A2, the main motive is to win the game. They should win the game. So how the competition will be adopted in both A1 and A2. So competition, while coming for competitive environment, we need efficient search algorithm that is called adversarial search. Before moving to adversarial search algorithms like minimax algorithm, alpha beta pruning algorithm, we will see the basic concepts of game theory. Game theory is a branch of economics, views any multi-agent environment as a game, that is competitive gaming environment, provided that impact of each agent on the others is significant. Because there is a chance to win among the two players, there is a chance to win only one player. So how much the impacts of each agent while taking the decisions will be reflected in the winning process. So in our terminology, this means, game theory means it should be deterministic, fully observable environments in which two agents act alternately and in which the utility values, will be affected based on the players taking the decision, and also affects competitive or opponent player what decision he is going to or she is going to take. So utility values or payoff values will be affected based on the player's decision. At the end of the game are always equal and opposite, which means if there are two players, if A1 wins, utility value might be 1. If A2 wins, utility value will be -1, which means A2 lost the game. If it is draw, we can define the value as 0. So utility values at the end of the game are always equal and opposite. For example, if one player wins a game of chess, the other player necessarily lose. So it is this opposition between the agent's utility function that makes the situation, that means that makes the situation adversarial. So before going to minimax algorithm and alpha beta pruning algorithm, we will see some of the terminologies. Game is nothing but interaction between two or more players. It might be two players, if it is a two-player game, or more than two players, as I have already mentioned, virtual football players, there are 11 players. So two or more players in which each player's payoff is affected by their decisions and the decision made by others. So the player's payoff value will be affected by their decision and also the decisions made by the others. Next is player. This is the interdependent agents of the game, which might range from individual to many. Next is actions. Actions strictly define behaviors that a player has to choose. So, what action they are going to take? For example, if it is a chessboard game, they will move the coins accordingly. How or what the opposition or opponent move the coin. Alternatively, the player should move the coin. If it is a tic-tac-toe game, if whether they are putting X or O based on the player's game. Next is payoff. Payoff is nothing but the utility value. It will increase or decrease within the system based on their decisions. Next, a game can be formally defined as a kind of search problem with the following elements. So S0. This is the initial state which specifies how the game is set up at the start. For example, if you take chessboard, first the players' coins will be at the starting position. If you take tic-tac-toe game, initially it will be empty. So next is player. Defines which player has the move in a state. So if one player put X, other player will choose other than that player who put X in that particular box, he will put X or 0 in the remaining boxes. So action. Action, it returns the set of legal moves in a state. Result function, this is nothing but transition model which defines the result of a move, which defines what action the player is taking, it will get that result. Terminal state is nothing but if the game or if the player reaches the goal, which means if you take chessboard, if the player put a checkmate, the game came to an end. If you take tic-tac-toe, the player has put X in a diagonal mode, the game came to an end. So terminal state represents that if the goal reaches, then it is true, otherwise it is false, which means there are some more moves to finish the game. The last function is utility function, also called as objective function or payoff function, defines the final numerical value for a game that ends in a terminal state S for a player P. So if a player wins +1, loses means -1, if draw between the players 0. Okay, now we will see the adversarial search algorithm, which is called MINIMAX algorithm. This MINIMAX algorithm provides a optimal path or efficient path for the given two-game tree problem. So it's a perfect play for deterministic environment with perfect information. Basic idea is you have to choose move with highest minimax value, which means there are two players, one is min player, other one is max player. So min player always try to chooses the or always try to reduce the winning chance of max player. Max player always try to increase the winning chance of or increase its winning chance. So there are two players. These two players will choose move with highest minimum value or highest maximum value. So this is the function. Minimax is equals to utility. Max player will always choose maximum value. Min player will always choose minimum value. We will see this particular function with the help of an example. So Minimax algorithm, before going to the example, this is the example for tic-tac-toe game. Here we have two players, max player and min player. Max player will put X, min player will put 0 or O. So here initial state will be like this, it is empty. Now max turn is to put X. So here we will have 9 boxes, which means max have 9 possible ways to put X. So max has 9 possible ways to put X. So if you see the diagram, here they will have 9 possible ways to put X in the given box. If you take next min player, when it turns comes, he has to put 0 in the given box where max already has put the value X. So min is having now 8 possible ways to put put 0 or O. So like this, at the terminal state, like this, we will come to know, or we will have the terminal state where max had win the game or min had win the game. If min has win the game, the utility value will be -1. If max wins the game, the utility value will be +1. If the matches draws, the utility value will be 0. So this is the algorithm where we have max player and min player. So we will have two functions for max and min. So initially max value will be -infinity, min value will be +infinity, and how the game starting and how the game has to push max value, min value will changes accordingly. Max always takes the maximum value and replace with it. Min always chooses minimum value to replace with the value V. So max always tried, here the concept is max always tried to increase the winning chances. Minimum always tries to reduce the winning chances of max player. So before moving to the problem, we have to understand some 5 steps. We have to generate the whole game tree from root node to leaf node, and we have to apply the payoff or utility functions to the leaf nodes. And here the basic thing is we have to use depth first search algorithm for expanding the tree, and then after traversing to the leaf nodes, we have to back up the values from the leaf node towards the root node. Max node computes the maximum value from the child value. Min node computes the minimum value from its child value. When value reaches the root, optimal root will be determined. So this is the example. We have max node and min node and utility values 10, 9 and so on at the leaf nodes. So now by using DFS, starting from root node, we are going to traverse till leaf node, and we will apply back propagation, and we will apply the values to its parent node. So here the one important thing is we have to taking care of max player and min player. Max player always chooses the maximum value, min player always chooses the minimum value. So by applying DFS algorithm, we traverse first it traverse left subtree, then root node, and then right subtree. So it will reach traverse towards left subtree till reaches the leaf node. So once it reaches the leaf node, it will arrive with the value 10, utility value 10. This value will be back up to its parent node. If you see level 0, we will have max player, level 1 min player, level 3 max player. So if it is a max player, it always chooses maximum value. Now we will have only one value, so it will back up that value to its parent node. Then after reaching the parent node, it will traverse through right subtree till it reaches leaf node. Now it is 9. It will compare with the parent value. Here 10 greater than 9, which means max always chooses maximum value. So 10 greater than 9, so it will keep this value as it is. Now it will back up this value to its parent node and update the value 10. Once reaches its parent node, it will traverse to the right subtree. Once it reaches leaf node, it will assign the value 14, but keep it in mind at level 2 max player is playing the game. Again it will traverse to leaf node through right subtree. So 18, obviously comparing the value with 18 and 14, 18 is the maximum value, so it chooses maximum value 18 and updates the value. Again it backups to its parent node, but in this level min player is playing the game. So min player will choose as the minimum value. Compare 18 and 10. Among these two values, 10 is the minimum value, so it will keep as it is. Again this value will be reaches to root node and assign that value. Again it will traverse the right subtree of the root node. So same thing will apply here till it reaches, it will traverse, and 5 will be assigned to the max player. Then it will traverse to the right subtree. 4, max always chooses the 4. So 5 is the maximum. Then it will go to the back up this 5 value to its parent node, which is where min player is playing its turn. So 5, it updates value 5. Again it will traverse through its right subtree. So 50, it will assign 50. If you see here, while traversing through its right subtree, here leaf node is having 3. So because this is max player turn, it will compare the value 50 and 3, it will take maximum value 50. Now this value will be back up to its parent node. Here min player is playing the game. Here it will take minimum value. While comparing 5 and 50, it will take minimum value 5. And this value will be back up to root node where max player is playing. Here max player will always takes the maximum value. So compared to 5, 10 is the maximum, so it is keeping that value. Now we have reached the root node, and root node having the value 10. Once tree has been traversed till its leaf nodes, and root node having the value, now here we are having the value 10. Now we have to find the most convenient path for the root node to that leaf node. So here 10 is the value for the root node. Wherever 10 is assigned to the nodes, we have to take that path. If you see, this is the most convenient path to reach its leaf node for the max player. This is how Minimax algorithm works. Next algorithm is alpha beta pruning. So why we are going for this particular algorithm? In Minimax algorithm, we will have one drawback called, once the number of game states it has to examine is exponential in the depth of the tree, which means we have to examine all the nodes to determine a convenient path. So we should not leave any other node. We have to examine all the nodes to find the convenient path. But here in alpha beta pruning, it reduces the examination of all the nodes. It will examine only particular nodes to find the convenient path. So which is also known as tree cutting problem. So this particular technique to eliminate parts of the tree. Pruning is nothing but it will eliminate, it will prune the some of the nodes which is unnecessary to compute the path. So in alpha beta pruning, here same like Minimax, it also working like Minimax algorithm. Max always deals with maximum value. Min always deals with lowest value. Max always deals with maximum value. Min always deals with minimum value. Same like Minimax algorithm, alpha beta pruning also, it will compute the highest value for the alpha and lowest value for the beta. So alpha associates with max player, beta associates with min player. Only difference is, instead of examining all the nodes, in alpha beta pruning we will prune some of the nodes, unnecessary nodes, to take or to find the convenient path within a less amount of time. Here we have to keep it in mind, one condition is alpha is always greater than or equals to beta, or we can say beta always less than or equals to alpha. Based on this condition, alpha beta pruning will work. So in both min and max node, we written when alpha greater than or equals to beta, which compares with its parent node. So it will compare with parent node, it will determine the alpha value and beta value. The one condition is alpha is always greater than or equals to beta, or beta always less than or equals to alpha. This is the algorithm. So here we always assigns with minus infinity at the initial state, and we always assigns with plus infinity in the min value function. So here max always takes the highest value, min always takes the lowest value. With the help of this algorithm, we will see how this alpha beta pruning is working. So same example we are taking for, here we have max player value always associates with alpha, min always associates with beta, which will take the lowest value. So level 0 we will have max player, level 1 min player, level 2 we will have max player, and at the leaf nodes we will have the utility function. It will use DFS to traverse the tree. So first it will traverse to the left subtree till it reaches leaf node. So here leaf node assigns with the value 10. So back up this value to its parent node 10. Again it will traverse to, it will compare, before that it will compare with parent node, with its parent node, but here this parent node doesn't have any value, so that it will traverse to right subtree till it reaches leaf node. So here the value is 9. Here at the level 1 max player turn, so it will take maximum value. By comparing with the values 10 and 9, 10 is the maximum value. This value will be back up to its parent node. So in this level min player is working, so min player will always takes the minimum value. It will this particular node will compare the value with its parent node. Parent node doesn't have any value, so it will traverse to the right subtree till it reaches left subtree, till it reaches leaf node. So it will go till leaf node. 14 is assigned. So here the important thing is, in Minimax algorithm it will traverse to right subtree 2, but here we will cutting this particular tree, particular branch, because the condition alpha should always be greater than or equals to beta. So in this particular level max player is dealing, max player always associate the value with the alpha. In the above level min player is playing the game, min player always deals with beta. Here alpha value is 14, beta value it has to compare with its parent node beta 10. So 14 is greater than or equals to 10. So it will compare the value with the 14 and 10. Min player always chooses the minimum value. So obviously the condition is true. It won't traverse to the next level, or it won't traverse to the right subtree. It will prune this particular branch. So in this way alpha beta pruning is working. So this particular 10 will be back up to root node, then again it will traverse till leaf node. So 5 will be back up. Here it will compare with the value, but it doesn't have any value here. So obviously it will go and compare here. Here max value 5 is maximum, so max value 5 value will be keeping in the alpha. Now this value will be back up to its parent node 5. Here we have to, it will check with its parent node. Here beta is 5, alpha is 10. We have to check this condition. Yes, obviously alpha is greater than or equals to beta, so no need to traverse this right subtree. So it will prune this particular right subtree and arrives the value at the root node 10. So this is how it will reduces the time for traversing the whole tree to determine the root node. So here root node is 10, root node value is 10, and wherever 10 value is assigned, it will find that particular path. So this is the most convenient path for the root node 10. Okay, based on this we will see two gate questions. The first question is, in adversarial search, alpha beta pruning can be applied to game trees of any depth where alpha is the m value choices we have formed so far at any choice point along the path for the max player, and beta is the n value choice we have formed so far at any choice point along the path for the min player. So we have already know the concept of min-max algorithm and alpha beta pruning. It always takes in alpha, it always deals with maximum value, and beta always deals with minimum value. So based on this question and given option, alpha will be deals with highest value and beta will be the lowest value. In that way, option C is correct. Okay. Next question is, this question asked in 2025, previous question asked in 2024. So here they have given two game trees and they are asking to apply the alpha beta pruning and find the values of x and y. So they have given some option. We have to choose what x value will be, what y value will be. So in this given trees, two trees, we have to apply alpha beta pruning and we have to find the x value and min value. So alpha beta pruning always deals with the condition alpha greater than or equals to beta or beta less than or equals to alpha. So here at level 0 max player is playing, at level 1 min player is playing the game. So they have given some utility values. So by using DFS, it will traverse towards the left subtree till it reaches the leaf node. So here min value, here the utility value is 2. So before that we will assign alpha based on the algorithm. We will assign alpha is minus infinity, beta is plus infinity. So here alpha always greater than or equals to beta. Here we will have the 2. It will compare with its parent node. Alpha is assigned with minus infinity. So it will take the maximum value and replace with 2. So now alpha value is 2, beta value is plus infinity. So x, and after this it will traverse to right subtree. So here we will array the variable x. We don't know what is the value of x. So here min player is playing the game. So min player always deals with the minimum value. Beta should be always choose the value minimum of 2, x. So here, because beta should always less than or equals to alpha, here alpha is 2. So that means my x value is always should be less than 2. So x can be take the value minus infinity to 2. Next is we have to find the y value. So y value, here it will go. So alpha is equals to minus infinity, beta is equals to plus infinity. So here 5. So here 5 it replaces with 5. Here we don't know the y value. Y value always should be, y value, we don't know the y value. So we will find out little later. It will traverse to the right subtree and here we will have 2. Here alpha is equals to plus 5. So here y value should be always, here, because beta always less than or equals to alpha. So alpha is which means minimum of phi comma y. Beta value should be always min of phi comma y. So here y value, it has to choose y value accordingly, because beta should always be less than or equals to alpha. Alpha is min of phi comma y. So beta is should bound the value between min of phi comma y. So y should not exceed the value 5, so that it maintains the condition. So y value should be greater than, which means y value should be, because beta should holds the min of phi comma y. Y value will be anything between 2 and infinity. Whatever the value will be, beta always chooses min of phi comma y. So the value here will be greater than 2 till infinity. No matter what the y value is, beta is always chooses min of phi comma y. So minimum value is 5. It obviously it is obviously satisfy the condition alpha is greater than or equals to beta. So in that way, x is, the option will be B, x is belongs to minus infinity comma 2 and y belongs to 2 comma infinity. Thank you. We will be continued in next session.